Hello everyone, welcome back to the another session in design and analysis of algorithms. The topic name is non-deterministic algorithms. This topic you will find in unit 5 as topic number 1. Now let's get started. Basically, there are two words what we have to define. The first word is what do you mean by deterministic algorithms and non-deterministic algorithms. So if I can define you what is deterministic, you can understand what is non-deterministic. Or else if I define what is non-deterministic, you can understand deterministic, because both are opposite words, correct? Now let's talk about the definition of this. What do you mean by deterministic algorithms? The algorithms that we write usually are deterministic. That means each and every statement of the algorithm, I know how it works. If I write an algorithm for deterministic, now I'm just naming deterministic algorithm. If I write any algorithm, whatever statement I am writing inside of it, I will be knowing how it works. That means working principle of the algorithm known, and that is what deterministic algorithm. Now what is non-deterministic? The algorithm what you are writing are not defined how it works, because now let's see, algorithm non-deterministic will be writing some of the statements into it. All the statements working principle may be not known to the user what we are writing, but at least few of the steps are we know. That's what we could able to write the algorithm, otherwise we will not write, right? So deterministic is what each and every statement will know how it works. Non-deterministic is what if you are writing n number of lines or n number of statements into it, you know few of the statements how it works and few statements you don't know how it works. So this is what non-deterministic algorithm. From this you have to understand deterministic is if I write n lines of statements in the algorithm, all n lines I know how it works. If I write n lines of statements in non-deterministic, I do not know all n how it works, but I know few how it works, and that is the proof that I wrote this algorithm, otherwise I did not, correct? Now we'll move further to understand this thing. Now if algorithm is belongs to deterministic, because we have to think about deterministic only. The reason is if it is deterministic or if it is non-deterministic, few lines of statements are determined by us, only some are not determined, correct? So let us talk about what do you mean by this deterministic algorithm. The algorithm whatever we were considering of any example, you can take any example from the previous topics. Let's talk about the best algorithms for their solutions having computing times that clustered into two groups. The one group is what? Polynomial time and exponential time. The first group consists of problems whose solution times are bounded by polynomial time. That is, searching algorithm will take big O of log n. The best, I'm writing it here, it is best. You can take linear search also, but it takes big O of n, correct? Now I'm taking binary search. You can assume it is binary search, which with the time complexity which is taking big O of log n. Now and sorting which it takes big O of n log n, and string matching or string editing which takes mn, correct? Even your merge pattern also will take big O of mn. Now so this is what polynomial time complexity. I'm just dividing the algorithms into two groups. One is polynomial time, the other one is exponential time. The second group is made up of problems whose best solutions are non-polynomial or exponential, and those are traveling salesperson problem which takes big O of n square into 2 power n, and knapsack problem which takes big O of 2 power n by 2. Now let's see about this. if it is n square into 2 power n, if it is 2 power n by 2, it is exponential time. That means I'm generalizing these two. Traveling salesperson will take exponential time. Knapsack problem also takes exponential time. And this also, it takes polynomial time. Now, so here there are two classes of problems that are established. These are given the names NP hard problems, NP complete problems. Now, so we were having NP hard problems and NP complete problems. A problem that is NP complete has the property that it can be solved in polynomial time. If and only if all other NP complete problems can be solved in polynomial time. And if what is NP hard problem? Now, if an NP hard problem can be solved in polynomial time, then all NP complete problems can be solved in polynomial time. All NP complete problems are NP hard, but some NP hard problems are not known to be NP complete. Did you understand? I'll repeat. You might have understood this point that we can allow algorithms to contain operations whose outcomes are not uniquely defined but are limited to specified set of possibilities. The machine executing such operations is allowed to choose any one of these outcomes subject to a termination condition to be defined later. This leads to the concept of a non-deterministic algorithm. To specify such algorithms, we introduce three new functions which are choice, failure, success. Now, what is choice? Choice is arbitrarily choose one of the elements from the set S. Failure is it signals an unsuccessful completion. And success is signals a successful completion. Now, let us assume one example to understand what is non-deterministic algorithm. So, for this, we'll take some assignment statement. And that is, we'll take an algorithm. So, in that, we'll take an assignment statement. Now, algorithm n search a comma n comma key. So, basically, we have two searching techniques, linear search and binary search. Linear search computing time is big O of n. Binary search computing time is big O of log n. Now, we will seek for the best computing algorithm, correct? Now, there is an algorithm which is non-deterministic algorithm. So, here we'll be taking one array and the array size and the key element. Now, here, those are three functions what are required for the non-deterministic algorithm. So, choice is one function, success is the other one, failure is the other one. So, these are what three functions. The executing time of these three functions are what? So, a choice function will take one time, success 1 and failure 1. So, total it is what? Big O of 1. It is big O of 3 combinationally, but all will not execute, right? Choice will get execute, choice function will get called and either success will execute or failure will execute. If any of two are executing, that the time complexity will be of big O of 2. So, big O of 2 in the sense what? 2 it represents a constant time complexity. That means constant time indicates with big O of 1. So, big O of 1 is the best complexity. That means if a non-deterministic algorithm is proposed, then the computing time is what? Big O of 1. So, it seems to be the best time complexity than the previous one. Now, so if it is giving a best time complexity, it is very compulsory that we have to understand how it works. Now, let's get into this algorithm. Now, there is a function or searching algorithm with this inputs. Now, let come. J is equal to choice of choice function. This choice value should be what? This should be arbitrarily choose one of the element from the n. Let's talk that. So let's take some array of elements, that I am taking some array of elements, and those elements are some 10 15, 1, 2, 3, 4. The indexes are what? 0, 1, 2, 3, 4, 5 the indexes. Now j is pointing to the index. Okay. Now I have given choice of something like 3. Choice of 3. 3 is what? It has to select from the, it is a key, it is a element what I wanted to search, and this element should be from the set of n elements. What element I have given choice of 3. That means without performing any of the logic, I would be able to find out the index of j. Correct? So it takes only one time complexity. So when I print this choice of 3, then easily I am getting the index of 3, third element where it has placed. Now the thing is what? We have to understand all these are determined steps. I know what it performs. What I know here, key value, let's suppose key value is, out of this example, key value is something like 15. Now key is 15, a of j indexes from 0 to something. Now a of j is equal to k. That means a of j is 0, j is 0, a of 0 is 10, 15 equal to 10, match not found. Then we will be iterating the loop until you find. If you found in the right place, that key element is found in the particular index, then we will be writing that j index to out. Now my searching operation will be success. Correct? Now, so though I did not perform these steps, I would be knowing the perfect index of my key element. Right? So here, in why the reason I am calling this is non-deterministic algorithm, all these steps I know except choice. I do not know how choice works. Correct? A non-deterministic algorithm terminates unsuccessfully if and only if there exists no set of choices leading to a success signal. So this is what non-deterministic algorithm. Thank you all.